For generations, the edge of our solar system has whispered secrets, faint gravitational nudges, irregular orbits of distant objects, shadows dancing just beyond the reach of even our most powerful telescopes. We've listened closely, wondering if something or someone was out there. And now, for the first time, those whispers may have found their voice. It didn't come from a telescope lens or a probe gliding through space. It came from a mind, an artificial one, a quantum AI system operating with a kind of awareness, unlike anything humans have ever built before, has uncovered something extraordinary. Not by chance, not by anomaly, but through a focused, relentless journey into the raw, silent ocean of data captured by the James Webb Space Telescope. In this data, long thought too noisy, too chaotic, or simply too empty to reveal anything meaningful, the AI found a pattern, a recurring ripple in the cosmos, a signal too slow to be random, too consistent to be ignored. And its source? A massive, invisible force twisting the paths of Kuiper Belt objects far beyond Neptune. Scientists have spent years speculating about Planet 9, the theoretical heavyweight hiding in the outskirts of our solar system. But this is different. This time, the ghost may finally have a face. Let's go back. Not decades, just a few months. The James Webb Telescope, humanity's most ambitious eye in the sky, wasn't looking for Planet 9. It was searching for the earliest galaxies, studying the birth of stars, decoding the chemistry of distant worlds. But among the countless frames of deep field scans and infrared snapshots, there existed a background hum, gravitational hints and flickers of infrared light that didn't quite fit. Subtle, almost imperceptible, the kind of data most algorithms would flag as noise and discard without hesitation. But this quantum AI wasn't built for the obvious. Unlike classical algorithms that compare images pixel by pixel, this system uses the mind-bending principles of quantum mechanics, entanglement, superposition, and probability clouds. It doesn't look at what is directly. It looks at what could be and how likely those possibilities are to overlap, interact, or emerge into something real. It sees the universe not in snapshots, but in simulations, probabilistic echoes of truth beneath the surface. For 72 hours, this quantum AI locked onto the Webb data like a hawk watching ripples in a distant lake. It parsed terabytes of raw observations, layer by layer, calculating the likelihood of gravitational anomalies and matching them to faint trails of infrared light. It stitched together time-lapse simulations that didn't just watch the sky, they understood it. And when the calculations were complete, its final log was almost understated. Anomaly confirmed. Candidate object detected. But make no mistake, what the AI uncovered wasn't just statistical noise, it was a coherent pattern. A slow-moving, massive body whose gravitational pull aligned with precisely the kind of influence astronomers predicted Planet 9 would exert. It matched the expected orbital distortions. It even reflected just enough infrared light, faint but regular, to suggest something enormous drifting silently through the cold, distant dark. At first, the research team was skeptical. It's easy to doubt. For decades, Planet 9 has been a myth, chased by star charts and speculation. But this wasn't theory. This was data. Cold, precise, and unshakably real. The more they looked, the clearer the picture became. Not a photograph exactly, but a simulation so tight, so consistent with predictions, that it left even the most hardened scientists silent in their seats. Planet 9, if this object is Planet 9, is likely a gas or ice giant. Its estimated mass, between 5 and 10 times that of Earth. But its orbit is unlike anything in the inner solar system. It's not a perfect circle. It's a stretched, elongated path that could take tens of thousands of years to complete a single revolution around the sun. That orbit takes it so far into the void that sunlight barely touches it, which is why, until now, we never saw it. It was always hiding in plain sight, in the data, waiting for a mind sharp enough to see through the veil. This is more than just a new planet. It's a key, a missing piece of a puzzle that astronomers have been struggling to solve for years. Since 2016, when Caltech researchers first proposed the idea, the evidence for Planet 9 has been circumstantial, based on the strange clustering of orbits in the Kuiper Belt. Dozens of icy bodies far beyond Neptune all seem to be tugged into strangely aligned paths, as if herded by an invisible force. And now, that invisible force has a direction, a source, a face, blurred, yes, but visible, thanks to the most sophisticated computational system humanity has ever devised. The James Webb data wasn't the only breakthrough. It was the marriage of that raw, chaotic stream of cosmic information with the quantum AI's unique ability to interpret complexity that made the impossible possible. Where human eyes might have seen fuzz or void, the AI saw architecture, probability fields, light curves, infrared shadows bending gently around something massive and unseen. This wasn't an image. It was a dynamic model, a living, breathing simulation of where Planet 9 might be, not just then, but over time. A ghost trail across the cold outskirts of our solar system. The AI tracked its probable location, updated its position based on gravitational feedback, and flagged a zone in space unlike any other. That zone now is being watched. But the discovery didn't stop there, because the object's movement didn't quite match expectations. It wobbled, not wildly, but subtly, like a candle flame shifting in a breeze. And that wobble, it could mean several things. Perhaps Planet 9 has a moon, a small companion orbiting it, throwing off its center of gravity. Or maybe it's surrounded by a ring system, or a cloud of debris, making its movement unpredictable to our current models. Even more curious was what came next. The AI detected a pulse, not a sound, not a light, but a rhythmic change in the object's infrared reflection, a faint pulsing pattern repeating at regular intervals. To some, this might be explained by natural thermal variations or shifts in radiation, but others aren't so sure. A regular pulse, at that distance, from a body that should be nearly inert. The implications are staggering. Could it be a mistake? An artifact of the data? Maybe, but maybe not, because the pulse matches no known natural object at that distance. Some whisper that it could be artificial, a signal, a flare, an echo of something far older than our sun. Suddenly, we're no longer talking about a ninth planet. We're talking about a relic, a monument, or something even stranger. And the deeper we look, the deeper the mystery becomes. For decades, astronomers had only suspicions. There were whispers of something strange, something off, in the way the outer solar system behaved. Objects on the edge of our planetary neighborhood didn't orbit the way they were supposed to. They moved like dancers out of step, their paths clustered, tilted, influenced by some unseen conductor beyond Neptune. But we couldn't see the hand moving them. And so the idea of Planet 9 was born, not as a certainty, but as a question, a gravitational ghost, a missing puzzle piece. In 2016, that question became sharper. A group of astronomers from Caltech looked at the behavior of several Kuiper Belt objects and realized they were all behaving oddly. Too oddly for coincidence. Their orbits were elongated in the same direction, as though they were all being nudged by a massive object, a planet far larger than Earth, that no one had yet found. It was a thrilling possibility, and it set off a global hunt. But finding a planet that doesn't want to be seen, one that takes tens of thousands of years to complete a single orbit around the sun and reflects almost no light, was like trying to catch a shadow in a cave. Telescopes scanned the skies, datasets were combed through, and yet, year after year, nothing definitive emerged. Until now, the James Webb Space Telescope was never built to look for planets in our own solar system. It was designed to peer into deep time, to see the afterglow of the Big Bang, to gaze at galaxies billions of years away. But its instruments, so exquisitely sensitive to faint infrared light, proved to be the unexpected key. JWST's deep field scans of the sky included images of the outer solar system, frames brimming with noise, with flickers of radiation too dim and jumbled to interpret by eye or even by classical computation. Then came the quantum AI. This wasn't a regular algorithm. It didn't look at the images like we would. It didn't scan frame by frame or try to pick out shapes. Instead, it interpreted the data probabilistically, like a mind that could exist in 1,000 states at once. It took the vast, chaotic noise and saw through it like fog clearing over a valley. For 72 hours straight, the system combed the raw data, running calculations at speeds unthinkable for any human. It mapped tiny, barely perceptible movements in background stars. It charted gravitational distortions so faint they had been dismissed for years. And then, there it was, a pattern. Something was moving slowly through that darkness. Not a star, not a comet, a mass large enough to tug on the orbits of Kuiper Belt objects, a silent shepherd in the deep. And more than just a gravitational nudge, there was heat, faint, consistent, measurable, infrared radiation, just enough to betray the presence of something big and cold and very, very real. The system's final log entry was chilling in its simplicity. Anomaly confirmed. Candidate object detected. This wasn't a fluke. The AI had processed billions of data points, traced them against known physical models. Log compared them with gravitational anomalies logged over the last decade. What it found wasn't just noise, it was a signal, a consistent, evolving, location-specific distortion, like a drumbeat buried under static, like the footstep of a giant in the snow. At first, scientists didn't believe it. They couldn't. But then they did what scientists do best. They tested, reran the data, adjusted the variables, tried to prove the AI wrong. But with every pass, the model held. The coordinates narrowed, the signature sharpened. It's not a photograph. Not yet. What we have is something even more compelling. A dynamic reconstruction. A model not just of where the object might be, but how it moves, how it pulls on its surroundings, how its faint warmth pulses through the void. And that's where the mystery deepens. Because something doesn't quite add up. The object moves, yes, but not smoothly. Its path shows irregularities, a subtle wobble. At first, astronomers thought it might be noise in the data, but the wobble persisted. Regular, predictable, like the object wasn't alone, like it was being tugged, maybe by a small moon, or a ring system, or a cloud of debris, or maybe, just maybe, something stranger. The heat signature itself pulses, not randomly, but rhythmically. At first glance, it looks natural. Planetary processes, internal heat. But the rhythm is too precise, too uniform. Some scientists have suggested it could be caused by geological activity. Maybe the object has an internal heat engine, but others aren't so sure. Because when you see something pulse like that, like a beacon, like a heartbeat, you can't help but wonder. Could it be artificial? It's a question no one wants to ask out loud. Not yet. But the speculation has already begun. Could this be a remnant of an ancient system? Could it be technology left behind by something long gone, or something still out there? Most scientists are cautious. They point to natural explanations. That's what science demands: skepticism, rigor, restraint. But even among the cautious, there's a sense of awe, a sense that something extraordinary is unfolding, Because even if it's not artificial, even if this is just a planet, a lonely gas giant drifting at the edge of our system, its discovery would still be revolutionary. It would reshape our models of the solar system. It would prove that planets can hide in plain sight. It would tell us that the cosmos is not static, but full of secrets waiting for the right eyes and the right minds to find them. And the quantum AI, it's just getting started. This was only one data set, one analysis. But now that the door is open, others are walking through it. Teams around the world are racing to point telescopes, both space-based and ground-based, toward the coordinates the AI provided. New data is being streamed, cross-referenced, compared with decades of observations, and everywhere, one question is on everyone's lips. What else have we missed? If something this big, this massive, this influential, can lurk in the shadows for this long, what other giants are waiting? What other secrets does the dark hold? This isn't just about Planet Nine anymore. This is about how we look at the universe. It's about what we trust. Human eyes? Algorithms? Or something entirely new? An intelligence that thinks like nothing we've built before? One scientist, speaking under condition of anonymity, put it this way: we've always assumed the universe would yield its secrets slowly, one discovery at a time. But now it's like we've unlocked a vault. And inside that vault, so far, we've found a planet-sized shadow moving where nothing should move, pulling at space itself, glowing just enough to say, "I'm here." And maybe, just maybe, whispering, "Look closer." The confirmation didn't come with fireworks. It came with numbers, coordinates, confidence intervals, temperature gradients. The object, as defined by the quantum AI, is estimated to be between 5 and 10 times the mass of Earth. Its orbit? Highly elliptical, with a period likely between 10,000 and 20,000 years. It is, by all definitions, a planet, but one unlike any we've ever directly observed. For now, it's being referred to as a candidate object, but within the scientific community, many are already calling it what they believe it is: Planet Nine. The AI's conclusion was independently verified by two separate research teams within a week. Both used completely different methods, analyzing unrelated datasets from both the James Webb Space Telescope and the Atacama Large Millimeter Submillimeter Array. The result was the same: something large, dark, cold, and moving, exactly where the AI predicted. But what's shocking isn't just the discovery itself, it's how the AI found it. Rather than scanning for light or motion like traditional telescopes, the quantum AI interpreted gravitational interference patterns and subtle background distortions across multiple deep-field scans. It didn't look for Planet Nine. It looked for how space itself was behaving around it. That shift in approach rewrote the rulebook. And it's why people are calling this the beginning of a new era in astronomy. Still, there's a tension in the air. Planet Nine is not just a planet. It's a key to understanding the structure of our solar system and perhaps our place in the cosmos. Its presence answers questions we've had for years, but it also raises new ones, big ones. First, how did it get there? Did it form alongside the rest of the solar system, then get flung outward by gravitational interactions with Jupiter or Saturn? Or was it captured? An interstellar wanderer, a rogue planet that happened to drift too close and was caught by our sun's gravity. Both scenarios are troubling. If it formed here and was ejected, it means our early solar system was far more chaotic than we imagined, filled with violent gravitational battles we've never fully accounted for. If it was captured, then we have direct evidence that our solar system is not isolated, that objects, big objects, can enter from deep space and become permanent residents. Second, is it truly alone? Some of the data suggests this may not be a solitary object. The irregularities in its heat signature, the slight fluctuations in its orbit, these may be caused by one or more satellites or even smaller companion bodies trailing along. One model suggests the presence of an asteroid swarm locked in a gravitational relationship with the planet. Another, more speculative model suggests the possibility of artificial satellites, though that remains unproven and controversial. Still, no one can explain the rhythmic pulsing of its thermal emission. It could be geological, perhaps like cryovolcanic activity or internal convection cycles, but it's so consistent, down to the millisecond in some frames, that a few scientists have privately admitted it resembles a signal. Not a message, not something with modulation or encoding, but a regular emission pattern that doesn't match anything natural we've catalogued before. NASA has remained cautious. In an official press conference, Administrator Kalpana Trask stated, "This discovery, if confirmed, is one of the most significant planetary findings in recent history. It validates decades of hypothesis and expands our understanding of solar system architecture. But we are not yet ready to label it a planet until we have visual confirmation." That's now the mission: visual confirmation. Ground-based telescopes in Chile and Hawaii are already focused on the predicted location. The JWST team is preparing a new series of targeted infrared observations, and in a surprise announcement, the ESA confirmed that its upcoming Ariel mission, originally designed to study exoplanet atmospheres, may be reprogrammed to assist in scanning Planet Nine's region with precision spectroscopy. But behind the scenes, the conversation is shifting. Because if Planet 9 is confirmed, and if it is found to have captured objects orbiting it, or worse, if those objects appear engineered, then this stops being just an astronomical discovery. It becomes something bigger, something that brushes against the edge of the Fermi paradox, that long-standing question: if intelligent life is common, where is everyone? Perhaps the answer is that they've passed through, left traces, and we're only just now learning how to see them. The quantum AI, still nameless, is now being integrated into multiple observatories' data processing systems. What it found in the Webb data may be just the beginning. Already it has flagged several other anomalies: unexplained mass concentrations, faint temperature gradients, unusual orbital resonances in other deep sky regions. Each is now being reviewed by human teams. We are, in a very real sense, at the start of a new paradigm, not just for astronomy, but for discovery itself. The tools we've built are now seeing things we could not, and the universe, once an ocean of unknowable darkness, is beginning to light up in ways we never expected. As for Planet 9, it's still out there, invisible to the eye, silent, drifting on its immense ancient orbit at the edge of everything we know. But it's no longer hidden.